Okay, we're at section 128 now, and there's going to be materials here at 128. What are the materials? They're really materials to prepare you to do the exercises. We do recommend you read through the contents. We recommend you look at the examples and then get busy working the exercises. All right, my name is Ron Bannon. This is a draft version of my adaptation of Webster Wells's Advanced Course in Algebra, which dates back to 1904. This document, the PDF version anyway, is being made available to the Prison Mathematics Project participants only. I realize other people may be watching these videos, and if you are and you're interested in getting a copy, it's not published yet, but if you email me, I'll let you know when it's going to get published and how to get it. My email address is Bannon, which is B as in boy, A, not an A, that's an at symbol, right? NNON.US. Yes, I'm in the United States. All right, what's this all about? Well, it's about taking derivatives of a higher degree. Successively taking derivatives. There's notation for it. I'm going to use the standard notation that's used nowadays, all right? But successive differentiation. Sorry about that. We'll go through that. So certainly it goes through examples, and I want to go through that as well. But the bottom line is it's really kind of simple. And the thing about this, successive derivatives, generally speaking, do not get easier. But for polynomials, they get easy quick. All right? So what I'm going to claim over here is they want to take a derivative of this thing over here. But they want you to take it repetitively. So let's write this down. So I'm going to say y is a function of x, and that function is 3x cubed minus 9x squared minus 12x plus 2. Well, if you remember in the last section, what we did was we took a derivative, and we did it by rule and definition. I'm going to sort of like drop the definition now and just do it by rule. It's so much easier. What do you get? dy dx is the same thing as f prime, and we've done that before. What do you get over here? 9x squared. Again, this depends on your ability to do a prior section. Minus 18x plus 12. Now, someone says, what are they going to do now? And this is the part where a lot of students get confused. All right, we're going to take another derivative, and the way we write this down is write down f double prime. And what do you get over here? You would get 18x minus 18. All right? Now, I'm going to put this other notation down. But before I do it, though, I want to point out the prime notation is something that is not very informative. This notation is, and it's called the Leibniz notation. So what does it say? Take the derivative of y with respect to x. Now, if I want to write down this f double prime, it's the second derivative. All right? This is the first. Now I'm doing the second. It's going to be written down this way over here. The 2 goes on the d, and the 2 goes on the x. This is read as the second derivative of f with respect to x. Let's put the third derivative down now. Triple prime. What's that going to be? 18. What's the Leibniz notation look like? Not bad. It's d, the 3 goes on the d, y, dx, and the 3 goes on the x. This is the third derivative of y with respect to x. Let's put the fourth derivative down. And this is where things kind of get different. I want to tell you what, people have a tough time counting hash marks. So I'm going to say, once you exceed the 3, you are not to put down hash marks. What you're going to, or prime marks. You're going to put down the numeral. But unfortunately, if I did this, someone might think it's the fourth power. So we must put in parentheses. This is a modern convention. What does it say? It says the fourth derivative. What's the fourth derivative? 0. What's this thing over here going to be? D. The 4 goes on the D. And the 4 goes on the x. It's the fourth derivative of f, or the fourth derivative of y with respect to x. All right? Oh, by the way, the answers are listed for you. We have the notation down. Nice and neat for you, too. All typed up for you. Again, We do not use more than 3 hash marks or 3 primes. Once you exceed 3, you're going to put numerals down in parentheses to indicate a derivative. So when I put a numeral on a when I put a numeral in a parentheses where it looks like an exponent, it's not an exponent, it's a derivative, fourth derivative. All right, so what do you do over here? And again, it's not bad if they're polynomials. If they're not polynomials, this gets tough quick, right? These are all going to be polynomials. What do you do? Write the derivatives down. I use both the prime notation and I use the Leibniz notation. Leibniz notation carries more information, but the prime notation is fine at this point. All right, we're using rules. We're not using the definition. It takes too much time. I write down the prime notation, and I put down the Leibniz notation as well. All right, fourth degree, what I do, prime notation, and I also put down the Leibniz notation for you. You get the idea. There's questions for you to practice. All the work is written. I shouldn't say work, but the answers are down. There's really very little work here because they're polynomials. Polynomials are super simple, right? All the work is down over here, all right? By the way, this one's more difficult. 6-degree polynomial. It goes on, right? So we get to the 7th derivative where it tanks out at 0. And every derivative there on out is going to be 0. Every one. Derivative 0, 0. All right, Sage. I just want to briefly go through this for you. Looking at it, I want to point out what this is giving me over here. This says differentiate f of x. Well, what's f of x? This is f of x. And what do they want? They want the fourth derivative. That's what this 4 is indicating over here. Take the fourth derivative. You should be able to look at that and get that, right? Is our goal to use software? Well, eventually it is, but right now it's not your goal. Your goal is to play around with software. So this is computer algebra system. Sage is anyway. It's open source. Go to the website. You can download an interactive web-based application. And it can't hurt to start playing around with it. So in the future, when you actually have to use the software, you'll be more familiar with it. However, I will say this. If you believe I made errors in the work, you need to reach out to me to inform me that you believe there's an error in the work. How do you do that? Contact me by email. My email address is b as in boy, the @ nnon.us. If I make mistakes, I want to correct the mistakes. Thank you.